God, seems like 1,000 years ago. I fought my way out of that cave.
Hey, stop this.
Became Iron Man.
What is going on? Just play the project demo. Like, no need of all this because it carries marks and all, so like it's super important. Welcome to everyone. So this is the video for the demonstration of the project that was developed by group number 14 of the 6th semester project of Rama University of Applied Sciences. Here are the names of the team members of this project. So, first let's discuss what is the motivation for doing this project. So, we often see engineers and scientists measuring, the physical models that were developed by them for their experiment, or students develop physical models in their schools, colleges, or universities, and teachers often need to measure the dimensions of these objects and grade them based upon the measurements that they found. The problems faced by the professors look something like that, what you saw. So we decided to solve this problem. So we thought if we could develop a system that can solve this problem. Say for example, the professor needs to just take a picture of this model, say which is developed by a student, and upload it to our system as an input. The system is going to calculate the dimensions of the object and it is going to give the output to the professor. And the professor can repeat the same process for hundreds of students in the respective school, college, or university. That would make the task so much easier, right? So we started working on it. We started going through several research papers and we started researching on our own and finally developed a system.
Dracarys.
And here is the demonstration. So this is my computer and this is the final project folder. So this is the final project, the outcome of a project. So we can see user.py is a Python program that is a external program written by maybe anybody on the internet. So this is a library that we have built that is the outcome of this current project. And so this user.py wants to find the dimensions of some object. So what this does is it clicks the picture of an object and then uses this library to achieve so this is the final folder, and if we open it we're going to find 3 modules. The first one is the preprocess.py. This module takes the input image and converts it into a format that can be used by this finddimension.py module and dim.py to find the dimension of the input image. So that is totally what is going on in here. So if we open the images directory, we can see 5 images which are taken to test the system. So let us open the images and see. So in the image we can find 2 objects. The first object on the right side is the one that is directly taken from the industry whose dimensions are unknown, and the left one is a 1 rupee Indian currency. The dimension of this object is known. So the current project is using reference object method. This means that there must be a reference object in the image along with the target object whose dimensions are to be found out. So the reference object's dimensions are known, and the diameter of this coin is 24.3 millimeter. So there are 5 images that are taken to test the system. So let us briefly look at the code and see what's going on here. This is a user.py program. So this is going to import the final module, and the final module, as we can see here, consists of these 3 modules again. So this preprocess.py has a bunch of OpenCV and other algorithms that are implemented, and the findDimensions.py that finds the dimensions of the image. So I'm not going to explain this totally, so let us directly see the demo. So let us open the command prompt and execute commands to get the output and see for ourselves how the system works. So the command is python user.py, that is this file over here, space minus minus image. This means that the program needs an image to be taken as an input, that is in this location, final images, and any one of these images. So what we have to type here is final images, and let us say image3.jpg space minus minus width. This width is the argument, that is the diameter of the reference object that we have given, so that is 24.3. So if we hit enter, we're going to get, okay, this is a grayscale image, right? So this is a silver colored object and the whole image is converted into grayscale, and this is a blurred image, as we can see from the heading. So the image is somewhat blurred from the previous one, and if we go further, this is the binarized image. So what happened here is that the program distinguished the object from the background. The background is colored in black and the object is colored in white. There are some discrepancies here in the object, that is why it is showing black in color, but it will be modified in the next part of the program, which I'll be showing now. So if we go further, this is the canny edge detection algorithm that has been implemented. So this detects the edges of the object only and neglects everything else, and this is taken in the further step to find the dimensions. So if we go further, dilated and eroded edges. So this is the enhanced edges. So in the previous output, if we could see that some lines were missing, so that has been improved to get a more accurate result. If we go further, we can see that a green mark is seen on this coin, which means that the program has identified that this is the reference object which is on the left hand side of the image, and it has highlighted it, and the dimension is 24.16. so we have given the dimensions as 24.3, but it is 24.16 as shown here, because the apparent dimension of the object changes with respect to the angle in which the image was taken. So that is exactly what is happening in here. So if we go further, we can see that the dimension of this object is given, so which is 56.27 and 55.72. Although these two edges are exactly same length, if we measure physically, the system is showing it as 55 and 56 because these two edges are not exactly perpendicular to the camera through which this image was taken. So we need a camera with a higher focal length so that these both edges are within the range of the focal length, and 135 and 133 is the length of this object that the software has found out. So if we go further, the result has been enhanced again, and we are getting 56 and 55, 134 and 133. So the actual dimension of this object is given in the final report, and the comparison of accuracy and precision of different results has been done there, and this system can give up to 97 to 98% of accuracy. So that is the output of the system. Thank you for watching this video.